We're going to get started with something called the binomial probability distribution. And before we get into that, we'll take a look at what is known as Pascal's triangle. Now the triangle is easy to make, and the numbers that we put in are easy to generate as well. And we start building from the top going down. And we simply start with a 1 in the first bubble at the top of the pyramid. And I'm going to write a 1 here as well, and a 1 here as well. And the rule is simple. Whenever you have a new bubble, you have to look at the cells above it and add those together. So the next one down here, I'm going to write a 2 because we have a 1 here and a 1 here, and 1 plus 1 is 2. Whereas this one beside it only has a 1 because above it there is only the number 1 and nothing here. So that's going to be a 1 on this side as well. And we can just continue down. This is going to be a 1. Here we have 1 and 2, that's 3. 2 and 1 is 3, and 1 is still 1. The next row, 1, and then 4, and then 3 plus 3 is 6. And then we have 3 plus 1, and then we have 1. Next row is going to be 1, and then 5, and then 10. 6 plus 4 is 10, 4 plus 1 is 5, and 1 is still 1. The next row, 1, and then 6, and then 15, 20, that's 10 plus 10. And then 10 plus 5 is 15, 5 plus 1 is 6, and 1 is still 1. And I'll just add a couple of more rows. Yeah? So 1, 7, 6 plus 15, 21, then 35, 20 plus 15, sorry, 21 and 7 and 1. The next row is 1 and, 8, 28, and then let's see, that's 56, 35 plus 35 is 70, and then 56 again, 28, and then 8 and 1. Now, it would be fair to ask, what does Pascal's triangle do? What can we do with it? A few patterns can be seen in this. All right, if we look at the second diagonal down here, we have natural numbers, 1, 2, 3, 4, 5, 6, 7, 8. We could look at the sums of number for each row. We see 1, 2, 4, 8. That's going to be 16. And this is, let's see, 32, 64, 128, 256. And this is actually 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, and so on. And you get the idea, yeah? Now, I'm going to make some crooked diagonals down the side here in just a minute. Like that, and then like this. Let's see. Yeah, and the next one would keep going through these cells. And what we have here is actually what is known as the Fibonacci sequence. So that's 1, 1, 2, 3, 5, 8, 13, 21, 34, and so on. So these are Fibonacci numbers. If we look down the third diagonal, we have what is called pyramid numbers. And pyramid numbers, they look like this. So that's 1, 3, 6, 10, 15, 21, 28, and so on. And the reason they're called pyramid numbers is that if you represent these as dots, then these are the dots you need to make small pyramids. Yeah, and so on. And finally, my favorite is hockey stick numbers. Hockey stick numbers, if you start on the right hand side and you go down and you form a hockey stick like this, the sum of these numbers here will be represented by the end of the hockey stick here. So provided you start at the end here, you can go as far as you want. 1 plus 3 plus 6 plus 10, that's going to be 20. Or 1 plus 5 plus 15 plus 35, that's going to be 56. So it doesn't really matter where you start. This is going to work out, well, you have to start at the side there, but you can go as far as you want. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 is going to be 28. So that's how Pascal's triangle works, and we're going to see how it relates to probability, and the next video we'll be looking at the Galton board, or the Galton machine.